Okay, number one, you have a normal distribution. The mean is 10. Standard deviation is 1. Find the probability that z is less than 8.2. Number two, you have a binomial distribution. You're going to do 10 trials. Probability of success is 0.4. And you want the probability that you get 6 successes.
How many trials?
10. Number 3, you have a Poisson distribution. M is one-third. And you want the probability that x is 4. Are we on number 4?
Mm-hmm.
Okay. Number 4, let's do blast from the past. The derivative of sine x. And number 5 is the derivative of cosine x. So number one, it looks like it's 0.0359. Number two, it's, so on our calculator, we type in normal CDF. What did I say? 8.2. So I got to go, the mean is 10. I want to go at least 5 standard deviations away from 10 to the left. So I could go 0 or I could go 5, right? What'd you guys do?
-5.
-5?
Yeah.
So -5, comma 8.2, comma 10, comma 1, you get 0.0359. Number two, you're doing a binomial distribution, and you're using binomial PDF, and then it's number of trials, which was 10, comma probability of success, which is 0.4, comma how many successes, which was 6, and you get 0.111. Number three, it's Poisson, and you type in the M and the number of successors you want, right? And so 3.69 times 10 to the -4, or 0.000369. Number 4 is cosine x, number 5 is sine x.
Negative sine x?
Negative sine x.
Yeah.
Gosh, what am I thinking?
Star?
Star. Minus star for me.
It's crazy how I still remember that.
How,
I feel like I'll never forget that the derivative of science.
Yeah, you probably never will. Now, do you remember quadratic formula?
Negative b minus 3b squared minus 4ac all over 2a.
Yeah, not bad, not bad.
Do you remember how to derive the quadratic formula?
Taylor series.
I do, by completing the square.
Fun stuff.
What about the Lagrange error bound?
Oh.
Well, scarily enough is scarily a word. Scary enough. I could do that right now. And there would be years that I would have to like seriously do some major prepping for that because it gets so scary. But now it's just like, I'm over it. I overcame my fear of the Lagrange form of remainder. And you too must do that.
Remember there was like an N and a Z and an F.
There's an X, there's a Z, there's a N, there's an R, capital R sub N. Okay, can you take your homework out? This was from Hassan. Hassan. And you know what the new thing is? Like for some reason, I don't know if I mispronounced it or what happened? I know I didn't mispronounce it, but l'hôpital's rule. Like students are going la hôpital. Lots of students are. It's like, where did that come from? La hôpital, a hospital. Getting all kinds of. All right, so you didn't have too many problems, right? 3? Okay. All right. Okay. Now, I can't imagine that you wouldn't have your calculator, but you do have to write some stuff down for these. You can't just put answers. I'll tell you what the grading rubric has. Nice. Scary how many people are absent in this class.
Yeah, where's like
I don't know where most.
Monique?
Is Megan an interview?
Megan went to Berkeley or somewhere. College visit or scholarship something. All right, so, we did number 1, right?
Yes, we did.
We did
Okay.
A. We were looking at B.
Excuse me?
We were gonna do B.
I thought we did B, 0.246.
Yeah.
All right, number 2. The lists in the office building of a small city have occasional breakdowns. The breakdowns at any given time are independent of one another and can be modeled using the Poisson distribution with a mean 0.2 per day. Well, you know, that's kind of not realistic because if they're breaking down, generally it's the same reason why they're breaking down. It's not, but whatever. All right, A, determine the probability that there will be exactly 4 breakdowns during the month of June, and that's worth 3 points. So you get 1 point for saying that the mean is 6, because it's 30 days times, or 0.2. No, wait, what am I doing? Oh. Yeah, 4 breaks. So the mean is going to be 30 times 0.2, which is 6. And you're finding the probability that x is 4. So you have 6 to the 4th over 4 factorial times e to the negative 6, and you get 0.134. Are we good to go? Okay. B, determine the probability that there are more than 3 breakdowns during the month of June. So probability that x is greater than 3 is 1 minus the probability that x is less than or equal to 3. And you get 0.849. Yep.
How do you put A in the calculator? Or do you?
How do you put A in the calculator? It's Poisson
PDF?
PDF, and then it's the mean, which is 6,
Okay.
and then the number of successes, which is 4.
Because it comes up as 0.134 when you do that.
Right, that's what the answer is for A,
Oh, I thought it was. Oh.
0.134.
Okay.
All right, how did you do B?
1 minus Poisson CDF 3.
Yeah, got that? All right, C, determine the probability that there are no breakdowns during the first 5 days in June. So the mean for 5 days would be 5 times 0.2 or 1, right, the M.
Mhm.
And the probability that x is 0 is e to the negative 1, which is 0.368. So 1 point for, again, the M, and 1 point for the answer. Anybody do that differently? No? All right, D, find the probability that the first breakdown in June occurs on June 3rd. So that would be, the required probability would be e to the negative 0.2 times e to the negative 0.2 times 1 minus e to the negative 0.2. So what that means is that we don't want it to occur on the first day. It doesn't occur on the second day. So that's why I get my e to the negative 0.2s. But it does occur on the third day, which is going to be 1 minus the probability that it occurred on the
First 2 days?
first 2 days. Or 1 minus the probability that it occurred on, 1 minus the probability that it didn't occur. Yes? No or yes or what? Okay, so the probability that x is 0 is e to the negative 0.2, right? Because the mean for 1 day is 0.2. So on June 1st, I don't want it to occur. So that probability that it doesn't occur is going to be e to the negative 0.2. Do we all understand that?
Mm-hmm.
And the probability that it doesn't occur on the second day is going to be e to the negative 2. So I'm going to multiply e to the negative 0.2 times e to the negative 0.2. But on the third day, I do want it to occur. And that's gonna be 1 minus the probability that it doesn't occur. Does that make sense? And so that's how I get 0.122. E, it costs 1850 euros to service the lifts when they have breakdowns. Find the expected cost of servicing lifts for the month of June. Well, it's just going to be 1850 times the expected value, the mean, which is 6, so I'm going to get 11,100 euros. And then F, determine the probability that there will be no breakdowns in exactly 4 out of the first 5 days in June. All right, how are we going to do that?
One last probability that there are 4.
Okay, that's one way to do it. Wait, let's see. No breakdowns in exactly 4 of the first 5 days. 1 minus the probability that there.
So that means the probability that there is exactly 1 breakdown in the first 5 days? The 1 minus that?
No, I don't think we can do 1 minus. Now this has become a binomial distribution. Because now we have on each day, it either breaks down or it doesn't break down. Breaks down or it doesn't break down. You get it?
Oh.
So this becomes a binomial distribution, and so we have 5 out of 5 days. We want how many successes?
4.
The successes break down.
1.
1. And the probability of success is e to the negative 0.2. Or the probability that it doesn't break down is e to the negative 0.2. And we want 1 of those, and 1 minus e to the negative 0.2, we want 4 of those. And you get 0.407. Wait, did I do that right?
I think it's the other way around. I think it's,
What's the probability that it doesn't break down?
I think that's the one that went.
This one, right?
Yeah.
Okay. It depends upon how I want to look at this. What do I want? I want it to break down
One day.
in 1 day. Okay, so this is going to be the probability that it doesn't break down. That it breaks down, right? And this is the probability that it doesn't break down? Yes?
Yes.
Okay. And so we get 0.407. All right, that was a paper 2 question, and it was worth 13 points. And I have been noticing a lot of the longer problems, the section B problems, being Poisson distributions. But they like to kind of do that, combine a little binomial with Poisson. All right, number 3.